for joining me.
Thank you so much, Frances. Good morning, everyone. So we are going to continue with developing and what the semiconductor ecosystem means. And I think this is important because the semiconductor value chain is probably the most complex value chain we've ever built as humans. And it's like an iceberg, right? Most of the people only see 10% of it, but the volume and the size is underwater and you don't see it. And I want you to imagine that you own a very nice Swiss watch, a nice Rolex, and you see, it's beautiful, you see the hands, the sphere is very nice, but you don't understand what's inside. And inside that watch is a very complex mechanism, many gears working together synchronously, right? So Philippe, before we jump to IMEC, why is the semiconductor ecosystem so complex? Why do you need so much? For example, the reinvestment, the total reinvestment of the total revenue, the reinvestment rate is around 20% on R&D, 50% on CapEx, right? Why is it so complex? So give us how does the watch work inside?
I'm not going to talk about the watch, but inside the chips, for those who are not familiar with the technology, it's very unique, and it's all about billions. I think it's about tens of billions of R&D investment that goes into the field every year to generate hundreds of billions of parts that are being sold. And each of these parts contains billions of the same device that is being made and replicated on a chip. And the process for making these devices is very complex. We need to control processes at the nanometer scale. And the process, I think, modern technology is probably 200, 300, 400 process steps that you need to sequentially add together in order to actually make the product that we are selling in this industry. I think that is very unique. I cannot think of another industry where the product is so complex and distributed in, I think, trillions nowadays. So it's and therefore, I think the investments that we are making, the industry is quite conservative. I mentioned that before, because there's so much at stake. If you misstep in the development of one process step, if you miss a node, maybe you will survive. If you miss 2 nodes in the technology development, you drop out. And that's what we have seen around 2005 to 2010, where many companies dropped out of the scaling race because they missed on making the wrong choice on technology, or they were too late, and then they missed the market, and then that was game over for them. And so that's one aspect, and the other aspect is this complexity of processes. So we're talking about several hundreds of process steps, and different players it's so complex to control. I'm saying at nanometer scale, but I think we are moving to angstrom scale. And it's so complex to control all these processes. It's nearly impossible to have one company that is able to cover all the process steps. So companies have specialized into specific aspects of the technology. Some are very good in understanding how to deposit layers at the atomic scale. Others understand very well how to project a certain design onto a wafer, controlling at angstrom scale, et cetera, et cetera. And so that's, at least, even before we talk about packaging, just making the chip, it is aggregating tremendous know-how of very different, multiple companies in the field. And so that makes the fabrication of semiconductors so complex, and interdependencies between the different players. And that is just making the chip. Then we have already talked about the complexity of the supply chain for the packaging. That's another complexity where I think also the dimensions are not small, but there it's very important to standardize everything. So that's also important.
So you mentioned something very important, that is interdependencies. And let's do another Mentimeter, another light meter like yesterday. Raise your hand if you know what IMEC stands for, the letters in IMEC stand for. How many of you know? Okay, so IMEC stands for Inter-University Microelectronics Center. Inter-university, right? And it's exactly what you're talking about, right? In this super complex environment, you really need to be interdisciplinary. Not multidisciplinary only, but interdisciplinary. You need to put all the actors working together inside this. I'm going to go back to the watch. So inside this watch, there is a European jewel, and this is IMEC, because IMEC has managed to put many of these specific actors inside the same place to collaborate in a pre-competitive environment, right? So you are collaborating inside IMEC with many, many different companies that are outside the world are competitors, right? What's the success of IMEC in this collaboration? What's the anchor collaborations that you have inside that make IMEC so unique, right?
Right. Yes, I think we recognize quite early on that there are specific technological problems that all the companies in the field are facing. And before it moves into the specific improvement of the technology to make it manufacturable, there is a need for common research. And that's what we have done at first, I think, very much anchored on lithography. I think that was one of the first key program at IMEC, where we partner with ASML to work with the industry to develop the next generation of lithography. So that was 248 nanometer, then 193 nanometer dry lithography, immersion, and then today EUV and high NA EUV. And when you try to do the lithography, it's not only about projecting, it's also about the resolution of the resist, having the right resist that is used in order to transfer the light into a physical pattern on the wafer. And then it's about how do you transfer that mask onto the dielectric or the silicon. So you need to collaborate also with edge vendors. So we managed to understand also very well the key IP that each company in this complex ecosystem wants to protect, and which one is satellite. So it's very important in such an environment that each party recognize the, I would say, the core IP value of the other partner. Once you realize that, and you can define then a proper business model, IP model, where you can have these companies working all together for the same problem. Still, always being able to carve out with the proper firewalls, what we call private projects for each company, that they can also perform at IMEC. But the core of the technology development is common.
I think we are going to have further discussion on the IP. You mentioned something that is, I mean, part of the success of IMEC, right? Is this IP protection scheme. Of course, we will love to have a lot of IMEC. Each European country would love to have an IMEC in their country, right? Spain is very fortunate because IMEC has decided to come to Malaga, right? But there's always the risk of duplicity, right? I mean, creating the duplications in Europe, and we've been seeing how the ecosystem work in India or in Asia. What will be your solution for the fragmentation of Europe, and how can we make Europe more important in the value chain from your perspective and experience in IMEC?
Yeah, I think the recent development, at least the first version of the CHIPS Act in Europe, goes in the right direction. I've seen in the past in European projects, specifically for CMOS scaling, that I was involved 20 years ago, we could see that each large research institute in Europe, so back then was IMEC, CLETI, Fraunhofer, we were actually always proposing very similar topics within the projects, and then the funding was sprinkled between the institutes to please each of them. And at the end of the day, on the surface we were claiming that we were complementary, but frankly inside it was always more overlapping than it should have been. And now with the CHIPS Act, I think there's recognition and giving strong direction for each of the center to focus on a specific part of the technology development. So it's much more, I think, complementary today than it was 20 years ago. So that I think is going in the right direction.
So we should continue it, right? In the CHIPS Act 2.0.
Right. Yeah, I think that's certainly making sure that we focus technology development in each of the clusters that have been created. But I think there's more to do. I think on the packaging side, in particular, I think that there's more work to do in CHIPS Act 2.0. And on the design side, on the design side, I think there are new DT DT funding that is being created in order to promote design projects and finance design projects in Europe, facilitated by design enablement teams that are providing infrastructure for fabless companies to design. But it's only starting, so I think we'll need to continue this effort for 5-10 years in order to make a difference. Yep.
What about the demand? Sorry, I'm obsessed with the demand, right? Is it realistic to think about a Rapidus-like model? Maybe can you, I mean, most of you will know Rapidus in Japan, right? Where they aggregate the demand. I think it's NEC, NTT, Toyota, someone else I'm missing. Is it realistic to think in Europe of an entity, a joint venture equivalent to that supports the industry?
Yeah, I think it is possible, but we need, I think, industry leaders in Europe to also believe in what Europe can produce here. I had some discussion with our colleague with Frederick from former Ericsson. Then, yeah, today I think the large companies in telecom, for instance, we have 2 very large companies in Europe, but I think they go to the US in order to have access to the chip. We need, I think it was mentioned in the previous discussion, enforcing maybe some regulation to have these chips designed and manufactured in Europe. So yeah, I mean, the question is it economically?
Sorry, I would like to add something, Juan. I think before that, we need to follow Maria's advice on the clustering, right? Because I think there is in Europe, or even regional, what I see is that there is a strong misalignment between the actors, right? The final users' needs sometimes are very misunderstood by the providers, right? So we need this clustering in Europe to understand and to put together the final user with the R&D ecosystem, with the rest of the actors in the value chain, right? So we can align the market needs with what we can actually do, right? And before aggregating the demand, we still need to understand what can be done, what's the needs of the final actors, the final users, and what can we provide, right? And once we understand that, then we will understand what demand makes sense to be aggregated and which ones has to be externalized, right?